Welcome to Module 8 in 288M. You made it to Module 8, so we're getting close to the end. And we're going to talk about distributed file system and branch cache. A lot of people really like setting this up, much more than the VPN stuff we talked about in previous modules. So let's take a look at what DFS, distributed file system, and branch cache is. We're going to talk about DFS servers, replication, and of course branch cache as well. And these kind of both do the same thing but in different ways. So you can choose either DFS or branch cache. And there's two different types of branch cache. So let's talk about what this is. So what is DFS? Well, DFS is a role service. So you're going to install this in Server Manager and you're going to add it as a role. It enables you to group share from different servers into a single logical share called a namespace. And what's good about that is if either one of the servers goes down, then the other server will serve up the clients using the same name. So prior to DFS, if you had server 1 and server 2, and all the shares were on server 1, that server went down, the clients had no access. Same thing with server 2. Now what you can do is you can synchronize the shares between server 1 and server 2, have a shared name. Let's call it server 3, for instance. So both of them will respond to the name server 3. So server 1 or 2 goes down, it doesn't matter. Server 3 is still running as far as the clients are concerned, and that's server 1 or server 2 that's actually serving that up. So you also have a namespace root. That's a folder. That's a logical starting point for the namespace. We typically call our namespace root DFS, but that'll make more sense when you get into the lab. You have a folder target, which is a UNC path that points to a shared folder on the server. All right, so here is what DFS looks like in a Visio document. You've got client 1 and client 2, and you have server 1 and server 2 off to the right. So you have all your share names in the shared namespace called DFS server / all shares. So client 1 and client 2, they don't know what the name of the server is they're connecting to. All they know is they're connecting to DFS server all shares. And from there, they're connecting to either server 1 or server 2 without even realizing it. You also have the namespace server itself that manages the namespace. Typically, I don't set up a namespace server separate from the DFS. I make server 1 and server 2 both a namespace as well as a shared folder server. So that way you add some redundancy. But this diagram is showing it in a little different way than what I'm used to, but it does still work. So it increases the ease of access and the consequences of file loss. One way to help ensure reliable access to files is to use replication. So besides having a namespace server that more than one server answer to, so the clients can connect to just one name instead of multiple names, you also want to replicate that data between the two or more servers. And again, so if one server goes down, the data is in both locations. To use the namespaces in replication, you must install DFS namespace role service and DFS replication role service. So these are two different roles, and that's because some people don't want to do both. Some people want to do one or the other, and they do operate independently. But they're all accessed through the same console. And you'll see that console when we go through that exercise. So of course, you use the Add Roles and Features wizard in Server Manager, just like we always do, or you could go to use PowerShell to install DFS as well. Managing our namespace and replication using DFS, this is what the console looks like. So you see namespace and replication, as I mentioned earlier, they're treated completely separate, but they're all in the same management console. Now, if your server is a domain controller, you're going to see that this is already set up with a server inside it. It's going to show your domain controller. And that's because domain controllers use DFS to replicate Active Directory between the different servers. So you're going to say, hey, why is there a server already in here and it's already configured? Well, it's because it's a domain controller. So don't delete it or make any changes to it or you'll break replication. So there's two different types of name spaces, a domain-based or a standalone. Now we like the domain-based one because it allows us to use all domain servers. We can turn them into DFS servers. Standalone is a standalone, and you don't have to be domain joined. Very few companies do this because it's not as secure. So here are the settings when you go into the properties And you can set up various access to the shared folder permissions as well as to the namespace server. Here is the domain namespace. This is part of the wizard, by the way, that you get when you go to configure DFS. You can see, if you want to, you can check Enable Windows Server 2008 mode. I don't recommend this. I recommend that you uncheck this unless you have a 2008 server in your network, which of course we do not, because it uses an older version of DFS, which is buggy and is not as secure. So don't check that box if you can avoid it. There's the namespace that we talked about. You've got the name of the server namespace itself. So you've got the domain MCSA 2016. So in our case, it's going to say widgetllc.internal, and then /. Then you come up with the second part of this. In their case, they said all shares. In our case, in our lab, I believe we set it up as DFS, because that way you know that this is a DFS share. Just makes it a little bit easier, for me to understand what am I looking at. And if you have a standalone server, then you can choose that as well. But we're not going to be doing that in this lab. So you've got to add shared folders. So you already have to have a share on both of your servers when you go to set up DFS. So if the shares aren't set up, there's nothing to add into the namespace. So prior to all of this, you've got to set up your shares, which we do in the lab. So after we set up our namespace, so the clients can use a single name to access data on more than one server, then we got to replicate it. And so we've got to say, hey, this data has got to, any data that's put into DC01 or whatever server we're using has to also be replicated to number 2. And anything you put on 2 needs to be replicated back to 1. So there's 2 different types of replication groups. You've got the multi-purpose and the replication group for data collection. So you can read that and decide what you're going to be using. In our case, we're going to be providing fault tolerance and load balancing for file shares. Several features can be configured to meet bandwidth. So there's a bandwidth setup. And this is a really good feature, because if you have the DFS servers in 2 different physical locations with a slow network connection, then the way DFS works is in site A and site B, you have a file server that's running DFS. Then the site A folks will only access data on the DFS server in site A. It'll go to the local server rather than across the slow network connection. And site B will do the same thing. So there's got to be replication happening, right? So if a user makes a change or adds a file to the site A DFS server, it has to replicate to site B in order for the users in site B to be able to access that file as well. So the replication sometimes can use up a lot of your internet traffic between the 2 locations. So you can limit the amount of bandwidth that replication uses during the daytime and maybe open it wide open at night. That's typically what people do when they have a slow connection between their 2 offices. So there's different types of topologies. Just like when you set up a network switch, you've got different types of topologies. Well, same thing with DFS. Hub and spoke, full mesh, or no topology whatsoever. You can define them manually. So hub and spoke basically says you've got a main office, and then you've got all the spokes going to the different offices. I don't typically see that kind of a setup with DFS. Mostly you see the full mesh option where all servers mesh with all other servers. But if you have a very large organization, you may not see that. That may use up too much bandwidth. So here's your full mesh option that you can see there. If you had 3 locations, you would also see the hub and spoke option light up as well. But in this picture, clearly they only had 2, so that's why that one didn't show up. And then the no topology allows you to go in and manually set it up the way you want. Scheduling can help manage the peak bandwidth, as I mentioned before. You can say when it can use a lot of bandwidth and when it cannot. By default, it's full bandwidth all the time, so you'd have to manually go in and make those changes. And here's what that looks like. It looks a lot like the Active Directory box that tells you when users can log on. It's the same kind of thing. However, in this case, it shows bandwidth usage. So you can see in this bottom left area, it says full replication, or you can limit to a specific amount. DFS uses remote differential compression used to determine changes that have been made to a file and replicates only those changes. So rather than replicating the entire file like it did in older versions of DFS, it only replicates the incremental changes. So much more efficient than it used to be. So here is the option for enabling replication on this connection and using RDC. Definitely recommend using RDC. Every once in a while, RDC will cause corruption of a file, which is why it makes it optional to use rather than mandatory. But I would definitely prefer it because it is much faster. So how does this replication happen? Well, DFS creates what's called a staging folder. And that staging folder has a maximum size of 4 gigabytes. So you can have up to 4 gigabytes of changes that happen at once, and they all sort of back up like railroad cars. So if, as people are adding and making changes to files on one server or another, then it goes to the staging area, and then Windows decides, if a change happens on both sides at the same time, who the winner is going to be. It doesn't happen that often where somebody will make changes to the same file at the same time in 2 locations or more, but it is one of those things that does happen. So Windows has to account for some kind of change like that, and it has to pick a winner, unfortunately. So 4 gigabytes I find for a staging folder is not big enough. I think going to 10 gigabytes is good. If you go to bigger than 10, such as 20 or 100, then it tends to really slow the server down. It slows the replication down. If you go to smaller than 4 gigabytes, then replication could just stop altogether because it'll just back up and then just stop. And then you'll have to restart the service, reboot the server sometimes, and it's just a big mess. So I would recommend somewhere around 10 gigabytes for most small to medium-sized offices. For super high-powered servers, for large offices, you can definitely get away with something like 50 or 100 gigabytes, but not on, say, an average-sized server. Here's that conflict and deleted folder I was talking about with the conflicts, where you have more than one that has the same thing. So it will decide who's going to be the winner there. So here is the staging folder where the staging happens for the changes, and this is where you change it by default from 4 gigabytes to something higher or lower. And if you click on default path, you can decide where that is. Here's the conflict and deleted path, which is in the advanced tab. Looks pretty much the same as the previous one. So you can make that larger or smaller. And again, I would make that 10 gigabytes. DFS fault tolerance ensures continuous access to users' files. And that's really what this is all about. So we want to use a single name, and we want to have fault tolerance in case something happens. And that's what DFS does. It has a diagnostic report utility. So you can go in and look at the health, the propagation. You can do a test, make sure that it actually replicates from one folder to another. There's also command things you can do through PowerShell that you can tell whether or not replication is working correctly. Replication can be very resource heavy. So you can create what's called a clone. So you can eliminate a lot of work of DFS by creating a replication database. So to create a clone, you'll have to do this through a PowerShell command, and you can see the export DFSR clone. We won't be doing this in our lab, but it is certainly an option if you have a lot of extra hardware, where a lot of storage, things like that, where you can do this kind of thing. All right, so let's move into a completely different thing here, BranchCache. If DFS is not your thing, it's very resource intense, very heavy, you can go with something called BranchCache. Now, BranchCache is a newer technology, does something very similar to DFS. But DFS works fine whether you're using multiple servers in one office or multiple servers in different offices. BranchCache doesn't work that way. BranchCache works better if you have a main office and then you have smaller branch locations. So file sharing technology allows computers at a branch office to cache files retrieved from a central server. So when you go from a branch office to a main office, your access to that office may be very slow. So let's say user A goes in and opens a very large file. That file will come across the WAN, maybe through a VPN tunnel, whatever it is, and that user will open the file. So they close the file. All right, great. Now user B wants to access that file. You don't want to have that really slow access again. So the file is cached locally, at that remote site. So when user B goes to open it, it'll be opening it up locally rather than across the slow WAN connection. That's what branch cache does. Two different modes of operation, and it really depends on whether or not you have a server at the remote location or at the branch. So you've got distributed, it caches data among client computers. So in my previous example, if client A opens up this huge file, it's cached locally on client A. And then when client B goes to open it, it's actually going to open it off of client A's computer. Client A won't even realize it's happening. Of course, their computer might run a little slow for a couple of seconds. The other option is hosted, and that's when the data is stored on one or more file servers. So if you have a small server at this branch, then you can turn that into a hosted branch cache server. So instead of being that big file being cached on computer A, it's being cached on the small server at the branch office. So here's an overview. You've got the corporate, the main office, then you've got the hosted branch cache server and the distributed cache server. So you can see there's no server in the distributed side. In the hosted side, you do see a server. Distributed cache mode is the best solution for small branch offices when having a dedicated server is not practical. So you're going to be doing that kind of thing. Hosted is better, maybe a little bit larger size office where you can afford to have a server, and so it does make things run a little bit more smoothly. So when branch cache happens, here's how it handles it. File changes are reflected in the content information clients retrieve from the server. So basically any changes that are made are cached locally, and then those changes are then replicated back to the main server. There's two versions of content information. You've got version 1 and version 2, and it all depends on the age of your server, whether it's 2008 or 2012. So with version 1, changes made to a file require the client to retrieve the entire file, but version 2 does it incrementally. So how do we install branch cache? Well, we've got of course, the add server roles and features through Server Manager. So there's procedure to install and configure depends on the type of content you want to cache and whether you're using hosted or distributed content. So you can take a look at the graph there, and it'll tell you what you need to install. So you need to install the file server role, as I mentioned earlier, and the branch cache for network files role service. So you can see that's what it'll look like when you start going through this installation through, this is actually through group policy. Set the branch cache support tag on each shared folder that should be cached. So you've got to enable branch cache on the file server, allow caching on the share, and it puts a little support tag on each folder. To each branch cache on a web server or application server, install branch cache feature in Add Roles and Features, or you can use the PowerShell. So that's the web server role or an application using bits takes advantage of the branch cache service automatically. Configuring a server for hosted cache mode, you can see that you can use an SSL certificate, install the branch cache feature using Add Roles and Features or PowerShell. All right, so we got to configure the clients to use branch cache as well. Now we're back in group policy. We've got to enable it, and we got to set up how it's going to be used. So this policy gets pushed out to the client so that way they know, hey, I'm going to be used in a distributed type of branch cache. Otherwise, they will reject that option. So you've got to set that up in group policy. So you see open the GPO and navigate to the location and set it up. And there it is again, using the other option. There's the server for the hosted option. Now you got to configure the firewall. So you got to set up a special firewall rule because by default, the clients are going to be blocking these ports. So you set up the group policy to basically allow that traffic to come from that particular device. Otherwise, it's going to be rejected. All right, so we covered a lot of different things here. We got distributed file system. We covered branch cache, the two different types of branch cache. In DFS, we talked about namespace and we talked about replication. So lots of great things. And these are all things that are used in many, many offices and businesses, organizations. So when you get out into the world to do your job, you're probably going to be using one or both of these types of technologies in any Windows Active Directory environment, which most organizations use. So once again, if you need to find out answers to your quizzes, come back to the slide deck. A more complete slide deck is available in each of the different modules, as you know by now. I just covered what the main highlights were going to be, and also your reading assignments.